Okay, when you picture brain surgery, what comes to mind? Probably a super focused surgeon, right, in this really intense operating room. But what if I told you some of the most critical work, it happens way before anyone even picks up a scalpel? It's kind of like a high-stakes detective story. And the anesthesiologist? They're the lead detective, piecing together all the clues to keep the patient safe. So let's follow the evidence and see exactly how they crack the case.
So let me just ask you, what do you think is the most important part of a brain surgery? I mean, is it the surgeon's steady hand, all the high-tech gadgets, the whole team working together?
Well, the answer might actually surprise you. You could argue that the most crucial part happens before the patient even sees the operating room. It's all about that super detailed, meticulous prep work. That's what really sets the stage for everything to go right.
All right, so this whole thing we're talking about, it all happens before that first incision. Think of it like a deep dive into a patient's unique biology, all to build this kind of fortress of safety around them for the procedure.
Now, there is an official name for this whole investigation, of course. It's called the pre-anesthetic evaluation. And really, it's the formal assessment that maps out the entire plan for the anesthesia, from the moment you go under to the moment you wake up.
And the goal here, it's crystal clear. This isn't just about getting through the surgery. Nope. The main point is to minimize any and all potential harm or complications. Every single question they ask, every test they run, it all points back to that one, single, ultimate purpose: patient safety.
So, where does our detective even start? Well, like any good investigation, it begins with gathering intelligence. And where do you get that? Straight from the source, the patient. And let's be clear, this is not just filling out a form. Think of it more like a methodical interrogation. For example, a patient's history with anesthesia. That could hold massive clues about potential problems with their airway. Or their current medications. That's so critical. Something like an anticonvulsant can actually make a patient resistant to the muscle relaxants they need. You see? Every little detail is a vital piece of this puzzle.
All right, next up, our detective surveys the scene, so to speak, and that's the physical exam. Here, the anesthesiologist is looking for clues, both the really obvious ones and the more hidden ones, written right there on the patient's body.
And you'll see how different patient profiles present totally different sets of challenges. For someone who is obese, the detective is on high alert for things like a difficult intubation. But for a patient who is very thin or emaciated, the big concern might be frailty and just how will they handle the immense stress of surgery. It's all about anticipating problems before they can ever happen.
And there are other clues that are just as crucial. You know, their baseline vitals, that gives a reference point for what's normal for them during the procedure. Something that seems minor, like dehydration, can actually cause a patient's blood pressure to just plummet dangerously right after anesthesia starts. And that's the core of this whole investigation, finding these risks and neutralizing them before they ever become a real threat.
Okay, so with those initial clues gathered, the investigation goes deeper. Now it's time for what you could call a full system scan, following the leads through every single part of the body.
And one of the key things our detective is looking for is something called frailty. Now, this isn't just about how old someone is. It's really about their body's physiological cushion, their ability to bounce back from major stress. A patient who's frail just has less in reserve, and that makes them way more vulnerable to complications.
Now let's talk about another major clue: smoking. The risk here is, well, it's significant. We're talking about a 3-fold increase in complications around the time of surgery for smokers. That is not a small number. It's a massive red flag.
But here's something that might surprise you. Quitting smoking for just 24 hours can make a real measurable difference. In just that one day, the levels of carboxyhemoglobin in the blood drop, and that immediately improves how well the body can carry oxygen. It's just an amazing example of how this whole evaluation process can lead to immediate, positive changes for the patient.
The investigation also has to look back in time. For example, if a patient has had any kind of recent heart procedure, there are these really strict waiting periods before they can have elective neurosurgery. And these aren't just suggestions, okay? These are hard and fast rules, based on evidence, all designed to prevent a life-threatening heart problem during or after the operation.
Okay, but sometimes the case is especially complex. We're talking really high-stakes scenarios. And in those situations, our detective needs some more specialized tools to get an accurate read on what's going on.
Let's take a subarachnoid hemorrhage, for example. That's a bleed on the surface of the brain. In a case like this, the anesthesiologist can't just rely on a general assessment.
No way. They break out these specific, validated grading scales. It's like they have a special forensic toolkit just for this kind of injury.
So, the first tool in the kit is the Hunt and Hess scale. This one kind of looks at the case from the outside in. It grades the bleed based on the patient's symptoms, what you can actually see. It goes from grade 1, which might just be a minimal headache, all the way up to grade 5, which is a deep coma. And where a patient falls on that scale has huge implications for their prognosis and, of course, the anesthetic plan.
Then there's a second tool, the WFNS scale. This one adds another layer of more objective data. It actually uses the Glasgow Coma Scale. That's a 15-point test that measures a person's level of consciousness. This gives a much more precise and standardized way to measure the actual brain injury.
And finally, our detective analyzes the images themselves using something called the Fisher scale. This one looks directly at the forensic evidence, you could say. It grades the amount of blood you can see on a CT scan. Now, why does that matter? Well, because the more blood there is, the higher the risk of a really dangerous follow-up complication called a vasospasm. So in a way, it's about predicting the future. So, after all this work, after the interrogations, the physical exams, the full system scans, and all that specialized forensic analysis, where does this all lead? It all comes together in the final plan, the anesthetic blueprint. And this, right here, is the ultimate outcome of all that detective work. All those clues, all that evidence, it's all brought together to create a completely unique, personalized safety blueprint for that one patient. It's a strategy that's tailored to their body, their history, their specific condition, all of it designed to guide them safely through one of the most vulnerable moments of their life. Which really leaves us with this one final thought. In a world where every single patient is a completely unique case, how do you protect them? How do you guarantee their safety? Well, you do it by becoming a detective, by listening very carefully as every single body tells its own different story, and then using that story to write the safest possible next chapter for them.